Okay, so section 2.2 is about polynomials, and this is the first video. I'm going to again do a couple of videos here. This is the introductory one. In a polynomial, this is a p, by the way. A polynomial is an equation that looks something like this. And here's an example. And a couple of things you notice is that all exponents are positive whole numbers. And notice too that it's just it's just multiplying. This is called a coefficient, multiplying the coefficient times the power of x. So it's just multiplying and adding is all you're doing. And so even though it has a lot of terms, it's considered a simple function because you can kind of see everything that's going on. There's nothing mysterious like a square root or anything like that. So there's a lot of notation in terms. So I just want to go over some of that, and then we'll do an example and talk about what I want you to look for. So there's the degree, and that's the highest exponent. So that would be n here, and here it would be 4. So in the example, it's 4. Then you have the leading coefficient, and that's the number in front of the highest exponent. And that's going to be 2. And there's just a lot of notation here. So notice here we have notation. So I just want to point that out, that 2 is A4, because that's the highest. A3 is going to be minus 3 in this example. And then A1 is the number in front of the x, so A1 is 1. A0 is the constant, that's 2. And notice we don't have an A2 here. So what we're going to say in this particular example here, in our example, A2 is equal to 0 because you don't see it. It's not there. Okay, so that's some of the terminology. And again, these polynomials are kind of important things in math, so it's like a basic function. So we just want to make sure we understand them. Okay. Now, a polynomial. So if we have a polynomial that looks like this, again, nth degree, I'll write that down. And again, you just write down a couple terms at the beginning and at the end. So this is degree n. We don't know what that number is. In the last example, it was 4. And this can, it doesn't always happen, this can factor like this. So we can factor into any number of terms. And I'm going to say m is less than or equal to the degree. So let me give you a couple of examples so we can see this. So we have f of x equal x squared minus 5x plus 4. We can factor this into x minus 4, x minus 1. And so here, this would be my example. We have, this would be R1 would be 4, R2 would be 1. Okay, notice I factored this into 2 terms. And notice that if I plug in R1 or R2, I get 0. F of R1 would be f of 4. So if I plug it in here or here, I'm going to get the same answer. So I get 16 minus 20, 5 times 4 plus 4, which is 0. If I plug it in here, and if I plug it in here, I'm going to get 4 minus 4, 4 minus 1, and that's also going to be 0. So these are called, these R1, R2 are the zeros. Okay. And just as a general rule, that if p of x is of n degrees, then the zeros, let me write that a better way. There can be up to n zeros. There doesn't have to be, and we'll see an example, but there can be up to that. Here's my example. N is 2, and you have 2 zeros. Let me give you another example. Okay, so here's another polynomial. P of x equal x cubed minus x. Okay. Now, I can factor this. There's a common term here, x, so I can factor that out. And now I can factor x squared minus 1. And notice that the degree is 3, and the number of zeros is 3. Okay. One more example. We're going to look at this example later. Let me write it down. Let me find it because I want to write it down. It's the one we started with. 2x4 minus 3x cubed plus x plus 2 has no zeros. And we'll see this from the graph. We'll see from the graph. So, in general, solving p of x equals 0 is difficult. And without luck, often impossible for us. Okay, and sorry, you can't see that. And again, I'll show you what I mean by that in a second. I just want to point that out. So let's look at this equation. F of x equals x squared plus 1. Sorry, I should have called that p of x. That's a second degree poly. Okay. And if I plug this into the quadratic equation, we could use this. So we can think of this as ax squared plus bx plus 1. And here a would be 1, b is 0, and c is 1. And then we can use this formula. Okay, so I do that here. I'm going to get, sorry, this is b right here, minus b. I'm going to get x is 0 because b is 0, plus or minus 0 squared minus 4 times a, which is 1, times c, which is 1, all over 2 times 1. That's going to be equal to plus or minus square root of minus 4 over 2, negative square root, so we have a negative number inside the root, so no solution. Now, notice that this equation can solve, so the quadratic equation, the quadratic formula, it solves all things that look like this. So we can find the zeros here. However, if the degree is 3 or higher, there's no formula we can use. So there's no formula like the quadratic. So we're lucky with the quadratic equation. Now, there are formulas for degree 3 and 4, but they're hard, and they're really beyond the scope of this class. But basically, there's not formulas, so we need to be lucky. So we need to be able to factor. I said before, so here's an example of when we got lucky. We were able to factor this. I can factor out an x. I have x in both terms. X squared minus 1. We can factor into x minus 1, x plus 1. So that's lucky. If I give you something like this, I'm just making this up. We're so out of luck. So it's not going to work. Okay, and that's what I mean, is we can't always solve this. So again, I just wanted to sort of introduce you to the idea of a polynomial, and I wanted to talk a little bit about finding the zeros and how that's hard I also wanted to introduce you to the notation, things like degree and leading coefficient. So let me just summarize this intro. And there's going to be a couple more videos with this. Is we want to know what the degree of a polynomial is. That's the highest exponent. I want you to know what the leading coefficient is. And I want to talk to you about the problem of zeros. Quadratic is easy. That's easy to solve. But if the degree of the polynomial is 3 or higher, generally we need to be lucky. We'd need luck to solve the polynomial equaling 0. Okay. So again, we'll do a couple more videos with some examples and some more material about this. Thank you.